Our lecture today covers equations of state. If you can still remember, an equation of state is an equation which relates the pressure, the volume, and the temperature of a system. Now, this system can be a pure component system or a multi-component system. Now, I believe that you are already well aware of the two of the simplest equations of state. We have the ideal gas equation and the van der Waals equation of state, which I think is already discussed in your FICM 1 class. So, to start with our lecture, so we start with the simplest equation of state, which is the ideal gas equation. PV is equal to nRT. So, the ideal gas equation, so it stems from a combination of the previous gas laws. We have Boyle's law, Charles' law, and Gay-Lussac's law. But however, in reality, gases do not behave ideally. That's why gases do not obey the ideal gas equation, or real gases do not obey the ideal gas equation. Hence, we have the modification by van der Waals. We have the van der Waals equation of state, wherein he introduced two variables, two correction factors, A and B, so that the ideal gas equation can be a more accurate model. So model siya, no? Model siya ang equation. P is equal to RT all over V minus B minus A over V squared, wherein we have two correction factors. We have A and B, wherein A and B are unique to every gas. So if you want to calculate for any of the parameters, usually what is asked is the molar volume. So you can just easily calculate that one using this equation, wherein A and B can be researched or can be obtained from the literature. However, in reality, we don't. At present, we do not use the van der Waals equation of state anymore. As you can see, that's proposed by J.D. van der Waals in 1873. Karaan, nakaayo siya. So actually, di na siya accurate karon. Maybe during that time, accurate pa siya, but now it's no longer accurate. However, the van der Waals equation of state has a lot of historical value. Historical value, that's because it is a stepping stone for different modifications of this equation until the scientists, the engineers came up with a more accurate equation of state. So, masya karaan na ni siya, no? So, it's actually the stepping stone of a lot of modifications to come up with a more accurate equation of state. And that is the focus of our lecture. So, if you have scanned the book, or better yet, you have read the text that I require you to study, so you might be baffled, no? Ikatanaw sus kapuyaan, daghan kay equation, di ka kasabot, di ka kasunod, mura kag mahadlong, katanaw pala mawad-an na kagana. So do not worry, actually sayo na siya, ato na pasayo nun, ay laghanap basa lang, paningkamot lang, hinahinayi lang, sayo na siya actually. And this lecture will try to help you para ato aning mapasimplify saon man jud ay ni siya. So if you have read the book, so we have different equations of state, natay katong virial equations, and we have the different cubic equations of state. We have the Redlich-Kwong, the Suave-Redlich-Kwong, and we also have the Peng-Robinson equation. Specifically, this lecture will cover the cubic equations of state from the Redlich-Kwong, Suave-Redlich-Kwong, and the Peng-Robinson. Okay, ang virial equation sayo naman to siya. Actually, you just have a set of formulas, then direct sum raman dyan to siya. And you have a sample problem, so you can just go over the sample problem. So simple na to siya ang virial equations. So karon, ang focus sa lecture is on the cubic equations of state. So mao ni sila. So the cubic equations of state, we have The van der Waals equation 1873 and its modifications to make it more accurate. So we have the RK, that's the Redlich-Kwong equation, which was proposed in 1949. RK, or rich kid in 1949. Then we have the SRK in 1972. SRK, super rich kid. Kakorny ba? SRK, that's actually Suave Redlich-Kwong. Then we have PR, which was proposed in 1976. That's the Peng-Robinson equation. So there is a book, in this edition of the book, PR pa siya, no? Now, actually, there are already a lot of modifications for the Peng-Robinson. Daghan-daghan na ubay-ubay na po ni siya ang modifications sa ani niya. So we have the Peng-Robinson, Strijek-Vera equations of state. Then naputay Elliott-Suresh-Donoghue equation of state. Maybe in the next editions of the book, i-incorporate na nila. But as for this edition of the book, which is used in the board exam, Peng-Robinson pa man siya kutob. So mo ni ang focus sa ato ang lecture. So normally in this problem, or normally in this topic, ang mga problems sa ani would require you to calculate for the molar volume. Remember that the ideal gas law is no longer accurate. That's why we have different modifications. So ang atoa ani is, atong focus ani are the cubic equations of state. So from the word cubic, sa pasabot ng cubic, meaning there are 3 roots. So there are 3 roots to the equation. So normally we have an equation for vapor, and we also have equations for liquids. So we will start with the vapors. So supposed to be, to calculate for the volume of vapor, we use this equation 3.49. As you can see, daghan kay siyang variables, or ay kahadlok ato ning pasayon nun. So this is the equation to calculate for the volume. But I will teach you more sayon. So simpler way of calculating for the molar volume. So ang technique ana sa pag-calculate sa molar volume, I don't use that equation, but rather I use equation 3.52 kanisiya. Remember Z in your FICM 1 class? But Z, this is also known as the compressibility factor. So first, I will calculate for Z. So mahadlok na sad niya mo ani na daghan kaayo og kuan mga variables ato nang i-discuss usa-usa. So we calculate for the compressibility factor first. So you might wonder, hala, Z pa man na. So then how do we calculate for the volume? Hinumdum mo sa inyong FICM 1, the Z, diba, Z is equal to PM over RT. So, diba, for an ideal gas, Z should be equal to 1, meaning PV is equal to RT. Diba, that's the ideal gas equation. So, to calculate for the volume, we use that equation, no, na Z is equal to PM over RT. So, first, we calculate for Z. Now, once we're done calculating Z, we calculate for the volume using that equation, no, this one. So V is just equal to ZRT all over P. Usually what is given in the problem are the pressure and the temperature given na siya. Then you are required to calculate for the molar volume. So saan na to? First we calculate for the Z, or the compressibility factor. Then once we are done calculating for Z, we calculate for the volume. Kani siya. So ato ning usa-usahon. So remember, we are talking about vapors pa. At this stage, we are talking about vapors. So ato ning calculate on usa-usahon. So calculate first for Z. So Z, let's try to check the variables. So we have 1. So okay, it's a constant. Then plus beta. So unsa man ni ang beta? So kaning beta, sulbununon pa po ni siya. There's an equation for beta. That's equation 3.53 kanisiya. So this is the equation for beta. So beta is equal to omega. So this is uppercase omega multiplied by PR all over TR. So unsa man ni sila? PR, that's the reduced pressure. TR, that's the reduced temperature. So sa sound pag-calculate ang beta, asa ni kwaon? So sa sound po nato. So sa beta, first, kailangan tag PR o TR. That's the reduced pressure and the reduced temperature. Asa man akwaon si PR o TR? So si PR o si TR, calculato na siya. So the TR, the reduced temperature, that's equal to the temperature divided by TC, which is your critical temperature. Your PR, or the reduced pressure, that's equal to your pressure divided by PC, which is the critical pressure. As I've said, the temperature and the pressure are given. So karon asa man ni kwaon si TC ug si PC. So TC and PC, these are unique to every substance. These are your critical values man ni sila. So asa man ni kwaon si TC ug si PC, we get it from literature. So in this case, we go to the appendix. So the appendix. So we go to the appendix. So we go to appendix B1. So sa appendix B1, so you can see here, we have different gases. We have methane, ethane, propane, etc. So si methane, na siya iyang critical temperature, napod siya critical pressure. So from this table, we can get the value of TC and we can also get the value of PC. Kani silang duha. Kwaon to na siya from the table. Then we substitute that one in our equation. So TR is equal to T over TC, then PR is equal to P over PC. So at this point, na natay value sa TR. Na-solve na nato si TR, na-solve na po nato si PR. So we go back to the equation for beta. Okay, so check na si PR ug TR, then the omega. Asa man ni kwaon si omega? So dili ni siya magdaog, depende sa unsa na equation of state imong gigamit, whether it's a van der Waals, whether it's Redlich-Kwong, Suave Redlich-Kwong, or Peng Robinson. So asa man ni kwaon si omega? We go to the next page. So in the next page, we have a table for parameter assignments for equations of state. So dire, so asang omega, dara si omega. So depende, no. So this is omega. Kung ang ipagamit sa imo kay Redlich-Kwong, we use this value. If it's SRK, we use this value. If it's PR, then we use this value. So depende sa equation of state kung siya calculate using Peng Robinson. So atong gamito nato is the value for the Peng Robinson. If it's as in the problem na using Suave Redlich-Kwong, then we use this value. Okay, so far ka-follow ra? So we already have the value of beta. So nanatay value of beta. So solve na si beta. So next atong solbon is the